All right, so again, I really want to try to get as much work as we can done in class today, so we don't have any homework. Again, about your calculator. Everybody can pull out a calculator, all right? If you don't have one right now, you got this whole long weekend to go grab yourself one. If you only have that one we've used the last couple years, you can use that to start out with, but I will be showing you lots of cool information with your graphing calculator, all right? So with that being said, all right, I now want to take a look at all these word problems. Now, let me look here. There seems to be 26. I'm not sure if I can get to all 26 of these, but I'm sure going to give it my best shot. All right, I think the initial word problems, I tried to make them a little bit easy just to show you the technique I want you to use. Most people think this is very difficult. All right, that's why we're starting easy and working our way down the page. My recommendation is don't just say that's the answer. Some of them are going to be obvious. You can look at it and say, well, I think I know what the answer is. Can I just do it and put the answer down? My advice is I'm not putting the easy ones on the test. All right, so there is a technique to do and solve word problems. All right, and I'm trying to give that to you. I'm trying to show you that technique. All right, in my opinion, you should not just ever look at it and say, well, that's the answer. All right, you're not doing yourself a service. You're learning to set up the word problems as we go down the page. They're more complicated. We're working on word problems for the next 2 weeks probably. All right, so you need to learn the technique early on. Early on, it's going to say, oh, that's easy. I can just tell you the answer. But we're writing out the correct way so when you get to the more advanced problems, they will be easy for you. All right, so here we go. It says a lion can run 18 miles per hour faster than a giraffe. So now what I want everybody to do, please do this. All right, there's a relationship between the lion and the giraffe. So I want to put L and G for giraffe. All right, now here, please. I know you know what the answer is. I know you can just tell me what the answer is. I don't care. I'm trying to show you how to set up a relationship when two things are related to each other. A lion can run 18 miles faster than giraffe. I have no idea what the giraffe can run, so I'm going to make him an X. All right, I'm going to make the giraffe an X. Then the lion would be what? The lion would be X plus 18. That's what that would be. That's what I want. I don't care about the answer. I want you to be able to write equations effectively. This is the introduction to that. If you just tell me what the answer is, it's of no value. I don't care what the answer is. All right? Now, it says, if the lion can run 50 miles per hour. So now we're taking the lion, which is what? X plus 18, and we're setting it equal to what? To 50. All right, now some of you, again, are not hearing me. I know you can figure that out without any work. I don't care about that. I care about, can you set up a relationship between two things that are related? Most people, guess what? Cannot. All right, do not take a shortcut right now. No shortcuts. All right, now, if X plus 18 equals 50, then X is going to equal what?
32.
32. Now, everybody, of course, is going to put 32 miles per hour. All right. Now, what does X represent?
The giraffe.
The giraffe. So did we solve it properly?
Yeah.
Yes, because it's asking for the giraffe. All right? What? No, I'm totally fine with what's on the iPad. All right, if you want to put giraffe equals 32 miles per hour, I don't care. All right, I'm showing you how I'm setting up the relationships. All right, here we go. Next, number 2. James ran a 400-meter race in 56.4 seconds. This was 1.3 seconds less than his previous time. All right? So again, right now, all right, we're talking about James running a race. James ran the race in what? 56.4 seconds. That's what we have so far. Now, it says from there, this time was 1.3 seconds less than his previous, all right? So his previous time, now listen to me on this. Is his previous time going to be more or is it going to be less than this time? And that's the tricky part. That's what we're trying to discover right now. That's what I'm trying to ask you.
It's going to be more.
All right? It says James ran a 400-meter race in 56.4 seconds. This time right here is 1.3 seconds less. All right? So that means the race before, he ran in more time or less time? He ran in more time. All right, so now, here's what I'm trying to tell you. Most people say that it was 1.3 seconds less, so without thinking about it, they just subtract and say 55.1 seconds. That's what they normally would say. All right, because they're looking at it and they say 1.3 seconds less, so they just subtract 1.3. All right? We don't know what the previous time was. We don't know what the previous time was. So I want everybody to write an X. Now, what happened to this? The previous time was what? 1.3 less. So that's when you're writing minus 1.3. You're subtracting 1.3 seconds from the previous time. And when we do that, that works out to be what? 56.4. All right? Now again, I am confident most of you guys already knew what the answer was. All right? I'm pretty confident with that. But what I'm trying to show you is we don't know what the previous time was. We know that the previous time is 1.3, or the new time is 1.3 seconds less than that. What? Connor, do you have a question?
Yeah, I'm just not understanding.
I'm trying to figure out what the previous time was. Right? We don't know what the previous time is. But we know this time is 1.3 less than that.
Oh, okay.
All right, what? That's right. So the final answer now to solve this is you're just adding 1.3. So the correct answer is actually what? 57.7 seconds. All right? That is an incorrect answer. Right? Trimble, what I was trying to show you, because people see less than, they automatically just do what? They subtract and think that's the answer. That's correct, because to solve that equation, you're adding 1.3 to both sides. All right, and this is where you got your calculator if you're not sure, and just 56.4 plus 1.3. I know that's not difficult, but still. Now, I've been saying over and over, I'm trying my best to make sure some of you guys that are like B and you want to make an A, I'm trying to help you. Right? And those of you guys who are trying to really improve, this is the time you got to speak up. All right? Now, I'm trying to make it clear to you what I was saying about, does everybody understand how an average kid might accidentally put down 55.1? Does everybody understand me? No, I'm not. I'll tell you when I'm finished, right? But again, you understand what I'm saying now, right? Because people see less than, they automatically just say subtract, and then they think they're right, and they just move on. All right? So again, what is important to me What is important to me is that you're able to do this. All right? This is honestly what I think is the most important part, that right there. All right? I know some of you just look at that and say, well, that's the answer. All right? It does get harder as the days go by. All right? So please, please, please listen carefully. I'm building right now. I'm building.
I always think of like equal on the other side.
Say it again. Come on.
Like, I feel like I'm gonna switch equal where
I know we're going to do hundreds of word problems. You're going to get better at it. All right? And I really feel like those of you guys who want to understand math, this is the critical point, right? Anybody can repeat information. It's the word problems that are the most important part because they're determining whether you understand what I'm actually teaching you or not. All right? So let me shut this door so I can hear. All right, again, guys, come on now. All right, let's read number 3 together. All right. It says, Aiden paid $4.75 for a sandwich, a drink, and French fries. He remembered that the drink and the French fries were $1.15, but he forgot the cost of the sandwich. How much was the cost of the sandwich? I know that is easy. I know that's easy. All right. But again, we're setting up an equation. Please do me a favor. Set up the equation. All right. So to set up the equation, we have the sandwich, come on, the sandwich plus the drink plus the French fries is equal to what? $4.75. Now I'm looking at what? The drink and the French fries cost what? $1.15. What?
Each.
$1.15 each. Right? So again, I'm just breaking it down. So it's going to be 1.15 plus the French fries is also $1.15, and that's 4.75. Yes, I know some of you just saying, well, can I just do 115 plus 115 and subtract and get the answer? Or can I just, I know all that, guys. You don't have to tell me that. I know. I'm breaking it down so when we get to the harder problems, you're not going to have an excuse. You're not going to have an excuse. You're not going to say, this is too hard. I don't understand what you're doing. And when you tell me that, I'm going to tell you the reason why you're not understanding is because at the very beginning, when I asked you to do it this way, you chose not to. All right, what?
Why did you put variable in the second one?
The sandwich and the drink. Oh, it was the what? The drink and the French fries, correct? So thank you. So it should be, thank you for correcting me.
I really wish you would have said you were always right.
All right, sandwich plus 1.15. There we go. Thank you. All right. So now, obviously, we have the ability now to do this. So we're just going to say the sandwich plus $2.30 is equal to $4.75. So that means the sandwich must have cost what? Come on now. $2 and what?
30 cents.
45 cents.
Tell me. Yeah, $2.45. Sandwich costs $2.45. Now again, that's why you have a calculator now. I don't care about the arithmetic because I've done everything I can to teach you the arithmetic. All right? Now you have a calculator. All right? What? All right, come on now. Simple equation. All right, let's go. Next. The perimeter of a square is 784 centimeters. How long is each side? Obviously, we would just take 784 and do what?
Divided by 4.
Yeah, divided by 4, but we're not doing that at this second.
Oh.
All right, we're not doing that at this second. How many sides on the square?
4.
4. Are the sides equal?
Yes.
Yes. So trust me, do this. 4x equals 784. That's what I want. All right, I promise you it's going to get much more difficult, and I can't say it over and over enough. We're building right now. All right, we're going basic. And then when you get to the harder problems, because you can set up the easy ones, you can set up the hard ones. What? I don't care. All right, so here we go. Now you can tell me what is 784 divided by 4.
196 centimeters.
So we're going to say 196 centimeters. All right, 196. All right, thank you guys. All right, here we go. William ate 3 of 8 pizza slices. He paid $5.40 as his share of the cost. How much did the whole pizza cost? Now this one's generally a little bit harder for kids. Do we know how much the whole pizza cost?
No.
So that would be what? That would be X, thank you. And he ate what?
3 out of 8.
3 out of the 8. And 3 out of the 8 is a what? Fraction. So we say, and this is the important part right here. He ate 3/8 of the pizza. Now X represents what? The entire pizza. 3/8 represents what part he ate. He ate 3/8 of it. And so now that is equal to what?
How much ever he paid.
$5.40. So 3/8 of the pizza costs $5.40. Now, how do you solve an equation with a fraction?
Multiply by the, or
Multiply by the reciprocal. All right, so those of you guys who have your handy dandy calculator out,
How do you do
just zip it. Here we go. Has everybody got the calculator? Right? Now, again, I'm going to show you 2 quick things on the calculator. All right? So I need your eyes up here. X, does everybody understand? X is equal to 5.4 times 8/3, correct? Right? Is everybody with me on that? All right? Now, just take your calculator and just go 5.4 times 8 divided by 3, because that's what a fraction is. A fraction is a division problem. All right? And so, Austin, the pizza would cost how much? $14.40. $14.40. So that is the answer. All right, we don't need the big fancy calculator for that. All right, we don't need the fancy calculator for that. But if you have your nice calculator, now is the time. Pull it up. I'm going to show you something. Here we go. Super important. Super important. All right. Now, again, for your fancy calculator, I want everybody to type in 5.4 times. Now, please, I'm not going to say this over and over. All right. On your calculator, there is what's referred to as a second. All right. I'm going to get to something else. So that second button, I think, is the blue button. So hit the blue button. Now, oh, actually, it's not the second. It's the alpha. I'm sorry. Right? No. Just watch and just listen. Alpha. Hit the alpha button, which is right under that. So it's alpha. And then I want you to hit the y equals. After you hit alpha and y equals, there comes up a list of things. Those are the fractions. All right? I want everybody to hit enter. Y equals, I'm sorry, is on the very top left. The very top left. All right? Y equals. Now, you're going to do 5.4 times, this comes up here, this comes up here, and now just do 8 and then go down and hit 3. And then hit equals. And it tells you the answer, right? So that's just your basic introduction to how to hit the fraction on the calculator. All right? So it's alpha y equals. Now, alpha y equals number 2 will drop you down to a mixed fraction. All right? But in advanced math, do we really use mixed fractions? No, we do not. All right? So we're very rarely going to use that mixed fraction button. All right. One more time. If you have short-term memory problems, you need to make sure that you're writing the information down. If I want to get to a fraction, alpha y equals. All right? That's what you're doing. All right. Now, is it necessary to do that, though? No, it's not, because we know a division is the same as the what? Fraction. All right, so there's really no point for the fraction. All right?
You can make it hard.
What?
You can make it hard.
I'm going to show you lots of things, Austin. You're going to be dazzled about how powerful that calculator is. All right? Here we go. Now it says here, the distance around the United States Pentagon building is 1 mile. How long is each side of the Pentagon in feet and in inches? All right, so first of all, who remembers the Pentagon and how many sides does a Pentagon have? 5 sides. All right, so now everybody's going to say, I don't know the length of the side, but I know that 5x is equal to 1 mile. Does everybody agree with that? Everybody? What? So, hey, come on. I'm not doing this the rest of the year. I'm saying you got to stay and pay attention. All right? When I'm talking, you got to be listening. All right? Now, how do I solve this? X is equal to 1/5. Now, this is something I want everybody to understand, right? If the whole thing's a mile, then one side of the Pentagon is going to be 1/5 of a mile. Now, of course, I'm struggling because most people don't know how many feet in a mile, but we all do. All right, how many feet in a mile? How many feet in a mile? Oh, I see some of you going to Google for that.
5,300.
Oh, close. Come on, what? What is a mile? How many feet in a mile?
5,600.
No! 65 feet in a mile.
5,280.
5,280. So now
Yeah,
listen.
because you looked it up.
Different
Listen,
breed.
listen, Connor. What you don't guys both don't understand is this is not a comedy club. All right? I'm tired of you interrupting class. You're not allowed to do it anymore. Tucker, you hearing me?
Yeah.
All right, I'm not interested in that. Just look up what 5,280 is. Let's go. Now, here we go. 1 mile. Now, please watch. I'm replacing the 1 mile with how many feet?
5,280.
5,280. So now we're taking 5,280, multiplying it by 1/5. All right, and somebody tell me what that is. That's what you have a calculator for.
56.
1,056 feet. That's the length of one side of the Pentagon. 1,056 feet. All right, now if you read, it says how many what? Inches. All right, it says how many inches. Now I'm sure everybody in here knows that 1 foot contains what? 12 inches. So now we're going to take this 1,056, replace the foot with what?
Inches.
How many?
12.
12. So now you're going to multiply 1,056 times 12. And tell me what that comes out to be.
12,672.
All right, and that would be inches. 12,672 inches.
But how many feet are in the line?
5,280. Shh.
Sorry.
Stop. There's no reason, right? I'm working hard. All right, I'm working hard on eliminating distractions in here. Here we go. Next. It says the Eagles won 3 times as many games as they lost. All right, now, do me a favor. Change 28 to 27. That was a typo on my part. So change 28, please. Erase the 28 and just put a 27.
Wait.
All right. I don't care what you do. It's your document. The Eagles won 3 times as many games as they lost. They won 27 games. How many games did they lose? Now, again, here's what I want. All right. Even though I know you know what the answer is, you have win and you have lost. All right. We don't know how many games they lost. We know that's X. You won 3 times as many games. So your the games that you won would be what, Tucker?
The games that you won.
would be what?
27.
No, how do I write that as an equation, or how do I write that as an
27,
expression?
27.
What?
X equals
27x.
You guys, come on, there. I can't help you. Some of you guys, you know, I'm just going to flat out tell you, I can't help you. If you can't look at 3 times x and say it's just 3x, I can't help you. If you're saying plus or minus or divide, there's nothing for me to do. All right, everyone in here knows what 3 times means. So the winning is 3 times the losses. That's what 3x is. All right? Now, what are we doing? We're saying we won 27 games. So if we won 27 games, 3x now is the number of games we won as an expression, and 27 is the numerical value of the wins. Now, of course, I know some of you already said, well, I already knew divide by 3. Yes, I know that. But I don't care. I'm going to keep saying that. Setting up the equations, the basic ones are the important part. So now I have x is equal to what?
9.
X is equal to 9. Now I'm going to answer the question. All right, how many games did they lose?
9.
They lost 9 games. Thank you. All right, so here, 9 losses.
9 L's.
All right. Now, how many games did they play then?
9 plus.
That's right. They played the number of games they lost and won, right?
36
So that would be a
games.
total of 36 games. That'd be a total of 36 games. All right. All right, again, the objective is to get a little better as we go down the page, setting up the equations. All right, I'm trying to tell you, I made them basic for a reason. So you would practice getting the experience writing the equation. If you're just telling me the answer, you're not learning. Write the equation. All right, here we go. A hardcover book sells for $16.50. The same title in a paperback book sells for $4.95. How many hardcover books must the dealer sell to take, or how about to what? To make, sorry, my secretary, they're typing. To talk to you about that. All right, how many books must the dealer sell to make as much money as she does for 30 paperbacks? All right, so we want them to be what? We want the cost to be what? Hello, we want the cost of the paperbacks and the hardbacks to be what? We want them to be the same, right? Isn't that what it's saying? Now, again, if you can't see that, I need to make sure I write that more clearly. How many hardcover books must the dealer sell to take in as much money as she does for the paperback copies? So you want them to be equal. Is that okay with everybody? Does everybody see that? All right. So how much money is she going to make if she sells 30 paperback copies? I don't care about the answer, but how would I find that out? What would I
30
do?
times.
Miss Bailey,
3.
I can't hear you loud and proud.
30 times 4.9.
Thank you so much. That would be 30 times 4.95. That would be the cost of the paperbacks. Now I'm trying to figure out how many hardcover books would I have to sell. All right? So I want them to be equal. So what's the cost of a hardcover?
$16.50.
$16.50. Now, do I know how many I have to sell?
No, so
No, so that would be X. So this right here would be the total amount of money collected for the hardcover. And this would be the money for the paperback. So now you got your calculator in hand. So what's 30 times 4.95? 148.50 equals 16.5x. And now how do I solve that? Divide it. Thank you. Divide by 16.5, divided by 16.5. So she would have to sell how many?
9.
Anybody else get 9?
Yeah.
Right now, look, I know some of you are like, wow, he's real good. Right, I'm just going to trust his numbers. Right, I see some of you with a calculator on your desk. You're not even using it. All right, and some of you are like, well, this is super easy. I don't have to do any work. I promise you, you're going to regret it next week. All right, I promise you, you're going to regret it. Please do the work. All right, we're doing it together. Come on, there's no reason to sit and watch people do the work. If you're not doing it on your calculator, open up your, and because y'all, I don't have a calculator, open up your iPad to calculator mode and do the calculations on your own. Don't just write down what other people are saying. That's the problem. Next. Here we go. The sum. What does sum mean?
Addition.
Adding. We must be adding two things together. What are we adding together? 38 and twice what?
2x.
2x equals 124. Beautiful. All right. So let's go. What do I have to do to both sides?
Minus 38.
Minus 38. So you got your handy dandy calculator. Subtract 38. And someone now is going to tell me that's 2x is equal to
86.
86. Now, final result is to do what?
Divide.
Divide by 2. So your answer should have
42.
been 43. Hopefully you did not do 86 divided by 2 on the calculator. All right. Hopefully you did not do that.
What would you divide 86 by?
2.
What's on the... Are you seeing it, or just is that just something your hand is? Okay, thank you. All right.
You don't have to learn line.
What?
That you didn't want.
Zip. Zip. You don't need to say anything. It's not positive. Here we go. Now I need help with 4 less than half a number is 17. How do I write it?
You do 4.
No. Right off the bat, I can say no. What?
1/2.
1/2 minus.
1/2 what?
Minus.
No. No.
1/2 x.
Hold up. Sean, go loud.
2/3 x plus.
How are we getting 2/3? Oh, you're doing number 11. I'm on number 10. Tell me. 1/2 x. Then what?
Oh, less than, or minus 4
Minus 4
Equals 2.
equals 17. All right, that's what we got. 1/2 x minus 4 equals
You
17.
can type that in your calculator.
How are you going to type that in your calculator?
You can do like letters.
What?
You can do letters on a calculator.
Austin, I promise you, I'm going to teach you how to use your calculator. No. No, you're not doing that on the calculator. You can't type the equation in yet. All right, so solve that. What do I have to do?
Add by 4 to isolate.
Right, so 1/2 x equals
21.
21. Now, how do I get rid of 1/2 x?
Multiply by the
Divide.
reciprocal.
Multiply by,
The reciprocal.
which is
2.
21 times 2,
42.
42. All right, number 11. Seriously, you need me. I need to show you how to solve that equation. We're in trouble if that's the case. All right, come on now. Number 11. I want to set this up, Sean. I'll let you do it. Yes.
2/3 x
Right.
4
Good. That's what I want. 2/3 x plus 4 equals 22. Now, we're going from there. What do I have to do?
Subtract by 4.
Subtract 4. So now I have 2/3 x equals what?
18.
18. Now do what?
Multiply by the reciprocal.
Multiply by the reciprocal.
You can divide by 2.
So if I multiply, that is going to be 18 times 3/2. Everybody type that in your calculator. 18, open parentheses, 3 divided by 2, close parentheses. That's another way you can enter a fraction on your calculator using the
27.
division. So now I'm at 27.
Why is that?
All right, anybody have any questions? How much time do we have now?
We have 3 minutes.
3 minutes. Okay, so listen, we're gonna stop here. We're gonna continue on Monday with one.
Tuesday.
But listen to what I'm saying, everybody. All right, and Connor, you know, I'm trying to make you better, right? Same with you, Tucker. Some of you other guys who want to get better. I'm fussing at you because I want you, that's part of the problem, right? I want you 100% focused on what I'm doing. All right, I'm trying to break you of all the other silly stuff right now. In class, I don't want silly. All right, I want you concentrating on what I'm saying. All right, now, again, for the rest of you, sit down. Sit down while I'm talking. All right, we're going to start on question number 12. I really want you to make sure that you have a calculator so I can continuously, Austin, every day I'm going to try to show you a little bit something different on the calculator. All right, and when I'm ready to show you how to do the variables on the calculator, I'm going to show you how to do it. All right, we're not jumping ahead. The most important part of math is being able to translate a sentence into a math equation. That's what we're doing. All right, so on Tuesday, when you come back, we're going to finish this up. I'm probably going to load the next word problems. We have word problems for 2 weeks. You're going to get better at it. All right, today is the beginning, foundation. All right, every day, build, build, build. And if you are struggling with this over the weekend, instead of doing nothing, go back and redo 1 through 11 and make sure you know how to do 1 through 11. Then when we start Monday or Tuesday fresh on number 12, you'll be good. All right, please pay attention. All right, no funny business. All right, have a great day. All right, kiddos, hopefully you got all that. Sorry I was screaming a little bit too much today, but that's okay. All right, you guys have a great weekend.
Thank you.